Welcome to the GATE lecture series. In our today class, anyway, we are looking into maxima minima. So far, we understood how to check at which condition maxima will exist, at which condition minima will exist, and then we also understood how to obtain the maximum value, minimum value when the interval also defined in the function. Now, in this lecture, we are going to learn something new. So, before starting into the question, that is looking into the question, if you are really understanding whatever the content that I am delivering, just click that like button and also share it with all your friends. So, now today lecture we are going to learn something new, as I told that. See, if you observe the question is find the number of inflection point. Find the number of inflection point for the curve y is equal to x plus 2x power 4 is dash. Sir, how can we obtain the inflection point? Basically, what is the actual meaning of this inflection point? Whenever it is given, first I will tell you how to solve the question, then I will tell you how to obtain it from the graph. So, if you are requested to calculate the inflection point, directly find the double derivative of the function, that is second derivative. What I have to do? You know y can be written as f of x. So, f of x equal to x plus 2x power 4. Whenever you are requested to calculate the inflection point, find f of x, take f of x, then find f double dash of x. In order to obtain f double dash of x, first you have to find f dash of x. F dash of x will giving you 1 plus, it will become 8x power 3, and then find f double dash of x. So, if I will find f double dash of x, 1 will become 0 plus 8x power 3 will give you 24x power 2. After obtaining f double dash of x, just equate it to 0, obtain the values for the x. Since 24x power 2 equal to 0, from this I can say x power 2 equal to 0 upon 24, 0 upon 24 will be 0. If I will pass x square to the right side, x will become 0 only. So, you will be obtaining some points like this when you are equating second order derivative to 0. So, when I am equating the second order derivative to 0, I got x equal to 0. Then take your function f of x once again. Okay, sir. What is the value of f of x? F of x is defined as x plus 2x power 4. X plus 2x power 4. What you have to do is, you have found that the value of x equal to 0, right? Now select 2 points from the 0. You know, from the x-axis, if you are staying at 0, the neighborhood points are in the right side, the neighborhood next complete integer value is 1. Right side, in the right side, the next complete integer value is plus 1. In the left hand side, the next complete integer value is minus 1. What you have to do is select 2 neighborhood points from the right side, 1 point from the right side, another 1 point from the left side. And then, so after selecting that, this is our original point. Add this point with the left hand side point, you will be getting 0 minus 1. Similarly, add this point with the right hand side point, you will be getting 0 plus 1. So, this will give you plus 1 resultant, this will giving you minus 1 resultant. Now, take your f of x, find the value of resultant addition for f of 1, f of minus 1. For f of 1, I am getting 1 plus 2 into 1 power 4. This will give you 3. Similarly, if you find the value of f of minus 1, that will give you minus 1 plus 2 into minus 1 whole power 4. This will give us plus 1 only. So, after finding f of 1 and f of minus 1, you have to check in resultant any one of these function, whether this resultant function is having sign changes or not. How should I check? Whether both are positive or one is positive, another one is negative, or both are negative. While cross checking this, first check, sir, there is no sign change since both values are giving positive. F of 1 also positive, f of 1 also, let me write like this, 1 minute. Yeah, sir, I found that f of 1 also giving positive value and f of minus 1 also giving positive value. So, the conclusion is, if you are finding, if there will be no sign change in the sense either they may be positive. Suppose in second case, no sir, I got for f of 1 I got negative value, f of minus 1 also negative value. See, in this case also we will be treating it as no sign change. So, in this case, in our question we got both are positive. Suppose in any other question while solving, if you are getting negative value also, you have to check whether the sign change is there or not. If the sign changes are there, sir, I have sign change, then you will have point of inflection. If there will be no sign change, then you can say, sir, there is no point of inflection. No point of inflection. In both of these cases, same answer. Suppose one is positive, another one is negative, then you can say, yes sir, at the selected point. When you are finding the second order derivative equal to 0, you found some point, right? At this point, you will be having point of inflection only when you have the sign change for the neighborhood points that you have selected. Since in our question we haven't find any point of inflection, it means, see, in our question there is no sign change. So the answer is no point of inflection at x equal to 0. We got only one value. Suppose, let me tell you, sir, while equating second order derivative to 0, if I am getting 2 points, like one point I am getting x equal to 1, another one point I am getting x equal to 5. How can I proceed further? Once again, take your x-axis, place the point 1. Next integer values. In the right hand side you will be getting 2. In the left hand side you will be getting 0. Now add 1 with the 0. You will be having 1. Add 1 with the 2. You will be having 3. Yes sir. Now find the value of f of 1. Find the value of f of 3. You have to cross check. If they are giving you sign changes, sir, I found, I am checking that the value of f of 1 is giving some value and f of 3 is giving. So you have to add these 2 points first of all. Or you can also directly check like this. You no need to add at all. So directly take the neighborhood points. Find the value at f equal to 0. Find the value at f equal to 2. Check whether these two values are equal. That will also give you accurate result. You no need to add at all. You can simply take C. Let me tell you, sir, at x equal to 1, you are finding 2 points x equal to 1, x equal to 5 by equating the second order derivative to 0. Directly take the neighborhood points. X equal to 1 means you have to take x equal to 2, x equal to 0. Then neighborhood points, left hand side neighborhood point is 0, right side neighborhood point is 2. Find the value of f of 0, f of 2. Check whether both are having sign changes or not. If they are having sign changes, yes, at this point we have point of inflection. If there will be no sign change, sir, both are positive, then there is no point of inflection. Okay, that is the conclusion. Similarly, I have given one more point, right? We are assuming that x equal to 1, x equal to 5. X equal to 5 means which point you will be selecting? You have to select 6, you have to select 4. Neighborhood points. Left hand side neighborhood point is 4, right hand side neighborhood point is 6. Find f of 4, f of 6. Check whether both are positive or both are negative. No sir, if they are having sign changes, one is positive, another one is negative, then at x equal to 5 you will be having point of inflection. Otherwise, there is no point of inflection. Now let me tell you what is the point of inflection. Actually, point of inflection in the sense, after the selected point, for an example, suppose you will be having a curve. You are observing a curve from the graph. 1 minute. See there. A graph is going like this. Now the given question is at x equal to 0. Whether the x equal to 0 is point of inflection or not. That is the question. What you have to do is take x equal to 0. Check the neighborhood point. See there. If I am selecting x equal to 1. X equal to 0 means you have to select 2 points. One is x equal to minus 1, another one is x equal to plus 1. If you observe at x equal to plus 1, your curve is giving some positive value. This is y axis positive zone. Whereas if you select x equal to minus 1, correspondent value if you observe, this is y axis negative zone. So what is the conclusion? Plus 1 is giving positive value, y means f of x only. So f of x is positive at x equal to plus 1, f of x is negative at x equal to minus 1. It means x equal to 0 is a point of inflection. So basically point of inflection in the sense, it is the point after which you will be having a sign change. It is the point exactly at which you will be having a sign change. It means I have selected x equal to 0. After this you may having positive values. Prior to that you might be having negative values for f of x. So point of inflection basically talking about the sign change of the function. So you can simply define like this. A point of inflection is a point on a curve at which the sign of the curvature changes. So inflection point may be stationary point, but there will be no local minimum, there will be no local maximum. Here minimum point, maximum point will not exist. After this point you may having positive values one side, you may having negative values one side. That is sign changing point from positive to negative, negative to positive, that is called point of inflection. So point of inflection is a sign changing point. After that point your function value may be going to it will be changed from positive to negative or negative to positive. I hope you all understood what is the actual meaning. How will you find this? Whenever in your examination requested to find out the point of inflection, take the given function, find the second order derivative directly and then equate it to 0, obtain the corresponding stationary point. Then if the stationary point is 0, select its neighborhood like -1 plus 1. Neighborhood points means for x equal to 0, neighborhood points are right hand side one integer value, left hand side one integer value. Neighborhood values means near value, you have to select the next nearest integer value. Substitute, check whether your function is changing its sign. If both values are selected, both values are giving positive or if both are positive or both are negative, then that point, selected point is not point of inflection. No sir, one is positive, another one is negative, then you will be getting point of inflection. So this is how we are finding the point of inflection. You know, most of the people, even I have been observed, only in this type of question, many of us struggled a lot. I know that. But now I hope you all having the clear idea how to find the point of inflection. Of course, actual meaning of the point of inflection also I have given. Finally, my suggestion is don't add, subtract anything. After equating the second order derivative to 0, suppose if you are getting x equal to 10, select the nearest integer values. At x equal to 9, x equal to 11. Find what is the correspondent value. No need to add this one with this one, this one with this one, that blah blah things at all not required. Simply find such that you will be getting the correct answer without any doubts. Okay, this is how we are obtaining the point of inflection. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.